Hello everybody and welcome to our RoadEng webinar today. My name is Jeremy Gonzalez and I've got Dave with me as well.
Good morning.
So today in our webinar we'll be talking to you guys about our OptiHaul Graph in RoadEng. It is part of our Optimal software, but we include it for free in RoadEng. So now I will pass the presentation over to David, who will start talking about our OptiHaul.
So RoadEng contains a lot of features that we have developed with our Softree Optimal technology. That's the software that will design for you a vertical alignment given various input parameters, constraints, and so on. That includes what we call the Opti-Haul calculation, and this is where we determine the lowest cost way to move material. We also include design time costing and smart pits. With the current RoadEng software, you don't have to pay extra for Softree Optimal to get these features. So all three of these features come with RoadEng out of the box. If you want to actually do vertical alignment optimization, then you would pay extra and get the Softree Optimal license. So a traditional mass haul is just a graphical representation of your earthwork. Accumulated cut minus accumulated fill, and it shows you the stations along the center line. The OptiHaul gives you a little bit more information than the traditional mass haul. It's first of all calculating how to move the material around to meet all your cut, fill, borrow and waste pits, and so on. It forces a balance, so if you don't have a balanced road, it will put in a pit for you. It'll tell you what material is moving where, which direction it's moving, and different materials get different treatments. They're separated in the OptiHaul, and it also keeps track of whether you're moving distance, a short distance or a long distance, and we call that movement method, free haul, overhaul, end haul. This is a picture of the OptiHaul graph, and now I'm going to carry on with some actual examples. So first of all, let's take a look at an example that you've all seen before. I'm going to open up the, okay, let's see if I can find it here. That one, yes. Okay. So here's the old Hart Road design, and I've got a kind of a small screen here today because we're making a movie out of this, so I'm squeezing things in to make a slightly smaller video. Hopefully I can make everything work. So this is a fairly typical design where you've got some cuts where we go through the hill here. We've got lots of fills on either side. Right now we're short of material. If I were to move this down a little bit, you get a more balanced road. And this is your classic optimal. Let me start that again. This is your classic mass haul diagram, which is showing the accumulated cut minus accumulated fill, and it's working from, well, there's a cross-section that has stripping. You can see that there's fill all the way down to the bottom of stripping there in the shaded area. If we look at this cross-section here, now we've got cut material. Notice that that cut material is actually three different, well, is it three or just two? Just two different materials because the top layer is stripped off. This material is GR, and yep, this material here is SR. There's your cut area shown in the pop-up there. Okay, so fairly typical. The mass haul diagram right now is not distinguishing between the two material types. It's just lumping them together. You can ask it to distinguish. This is version 7 technology. You can actually go in here and change what materials are displayed for cut and what materials are displayed for fill. However, there are some inherent problems with this because the old software never really paid attention to what material went where. And you may be aware that our software has the ability to allow you to choose materials in the ground. In this case, we've got 3 layers of material. And just for those of you not that familiar with RoadEng, you know that you should know that the layer interfaces can be defined by depth, as they are here, or by a surface. So you can actually have sub-horizon surfaces that are created in the terrain module. Okay, so we've got a great way of representing what material is going to get cut. But up until version 8, all you could do was define what material you believe was going to be filled in a certain station range. In version 8, we've enhanced that to allow you to choose the quality of material that's going to be filled and let the software decide what material goes there. And this way it can balance all the different quantities, and it gives it more freedom to move material around. Okay, so let's look at the results there. So this mass haul diagram is the way it used to look in version 7 and previous versions. Now I'm going to open up a design I've got saved here, this one. Okay, don't need that. Just move this over a little bit. So a couple of features that are important for the OptiHaul. One is the alignment properties panel, and the other thing is the OptiHaul graph itself. This is part of the profile window. There's your mass haul diagram, and looks pretty much the same as the other one, but there is a subtle difference here. The mass haul is set to use OptiHaul volumes here. That's important. And how did I get that OptiHaul in there? Well, first of all, you know that you can use screen layouts. So I can have a screen layout set up that will have all these windows and sub-windows and line types and fonts and all that. But to set up the screen layout, you need to go into Profile Options and add the OptiHaul item to your selected sub-window list. And there's your mass haul, there's your OptiHaul. Okay, it's in there now. And second thing you have to do to display the OptiHaul correctly is to actually do a recalculation. Now, I can't remember whether I set this up to do it automatically. No, I did not. So if I were to, for example, move this alignment here, let's do the same thing I did before, move it down a little bit. And notice that the mass haul diagram did not update. It just said out of date recast. So we've added a new feature to recalculate all. You can turn on that checkbox there. And that's handy when you do need to do a recalculate all, because it automatically recalculates the OptiHaul here. You can also use the alignment properties panel to do a recast. And if you turn this little checkbox on here, it will recast after every alignment change. Now this works great on a shortish design like this one, because it doesn't take long to recalculate the OptiHaul, but sometimes it's a bit slow and you might want to leave that turned off. Okay, so there, it's finished. That's the recast calculation. And I won't go into the multiple alignments right now. We're just using one alignment. That's fine. We do have multiple verticals here if you need them. So now let's look at the details of the OptiHaul. What the heck is going on here? Well, first of all, you'll notice that we still have the ability to change the mass haul to show different materials. That hasn't changed at all. It's just in the mass haul options here. This is important for doing an OptiHaul volume calculation and showing it in the mass haul. So here's the mass haul. This is now correct. Let's take a look at the OptiHaul diagram. So what's happening right now is it's showing you how the material is being moved. It's a complement to the mass haul diagram. We can see here that there's going to be movement ahead in this zone, and that's actually shown here. There's some movement ahead. These also notice that there's movement both ahead and back in the same location. The mass haul diagram can never show you that. This is going back because it's a different material. That's SR. This is going ahead. It's GR. That's because I did a request in my range here. I said I want a very specific fill material. Well, actually, it's not very specific. It's just high quality fill material. Anything that has Q4 quality 4 can be used in this zone. Why did I do that? You may have seen this in other examples. There's a culvert right here, and that culvert has quite a big fill over top of it. There it is. And I wanted to have a steep fill angle here, so I wanted to use this Q4 material, which is probably riprap or shot rock or something similar. And where's it getting that material? Well, you can see from the diagram here that that material is being cut in this zone, and it's being pushed over and filled in that zone there. There's also material coming from somewhere else. It says here that some SR is coming from this pit over here. So it's actually borrowing material, pretty sure. Pit waste. I don't see the exact information there, but there's a way to get all the details out of here. So first of all, hover tips are great. Yes, it is borrowing some SR, 2,500 cubic meters. So maybe I want to add that to my pits list. Let's just do that. So I'll go into options here, pits. Actually, you can get to this in the same place you always did in the old software. Assign parameters by range. It's in the home ribbon now, but it's the same dialog box. And pits is at the end. So now let's put in a rock borrow pit. Where should we put it? Right about, let's just say that we got lucky and we've got one nearby at station 500. So this is a borrow pit. It's going to yield for me some rock. I can actually change the cost that it's going to be going to cost to get a cubic meter of this stuff if I want. 20 is the cost in my other table. This makes me think I need to backtrack a bit and show you about the costing table, but let's leave that for just a moment. Okay, so I've got my borrow pit here. How much capacity? INF just means infinite, so I got lots of stuff available, and I'll just do that. Now, it needs to recost because that pit now exists in the middle of the road. Let's run it, and there's my borrow pit. It's now borrowing all of that solid rock from this pit right here, and we've got a tiny bit of waste material, which is, waste pit. Oh, distance zero, that's right, yeah. So we've got a tiny bit of waste material that's going into that pit over there. I don't think any's going in this pit. Oh, it looks like 18 cubic meters, not a big deal. Okay, so maybe I want to put in an explicit waste pit, I don't know. So the software is calculating not only the mass haul diagram, but also all the flow of the materials. And it's basing this flow calculation on some parameters that you provide. Again, I can get it through the alignment properties options here. but if you're familiar with RoadEng, you know that there's always been a ground types table. There it is, ground types. And this is the part of the ground types table that you're familiar with from old version 7 and previous. Click on costs here, and this shows you some new features that were added recently. You can put in the cost to excavate and place or embank material. Solid rock is harder to dig than gravel, for example. And it also allows you to enter haul costs. And I'm not going to go into the details of this. The concept is that the first one is equipment number 1, usually a bulldozer. The second section here would be equipment number 2, maybe a scraper. And the third one might be truck and bucket. Your cost is defined as dollars per cubic meter per kilometer. And usually this goes down as you change equipment. And then the loading cost. The bulldozer is the cheapest to load. The scraper takes a little more, and truck and bucket is quite expensive to load. And the software automatically calculates the turning points where you switch between equipment 1 to equipment 2 to equipment 3. And traditionally we call these free haul, overhaul, and end haul. If you want to have a 2-stage system, all you need to do is make 2 of them the same. So let's take the scraper out of there. So those are now identical. I click on update. We've now got only 2. Free haul goes up to 666 cubic meters, and then, or pardon me, distance 666 meters, and then after that is overhaul or end haul, whatever you want to call it. Okay, so costs are important. You can get at those from the ground type table. You can also get at them from the alignment properties costs button. Options costs, there we are, unit costs. And all the other stuff's in there too if you want to modify the ground table in any way. And as you've always been able to do, you can save your ground table, and then once you've got these numbers set up, you don't have to worry about them too much. You just use the right ground table. We changed the name. It's now called Normal GDX. It used to be called roadeng.gnd. Well, let's take a look at a couple more examples of how to use it. Oh, one more thing I want to show you here. Sorry. This is a very nice graphical representation of the haul. Let's look at a text representation or a spreadsheet representation. So I'm going to copy the OptiHaul to clipboard. By the way, some of you may know that you can copy the mass haul to clipboard, and that's been around for quite a long time. Let's just do that and put it in a spreadsheet so you can see the old functionality beside the new. Okay, here's my spreadsheet, and here is Control-V paste, the old mass haul paste. Don't know how many of you have been using that, but it's been in the software for quite a long time. It's a little bit hard to read, but basically the idea is that the first 2 here are your cut stations, so we're cutting from here to there, and then the last 2 here are your fill stations. We're filling from here to there, and you can line those up with the lobes in the mass haul diagram. Now let's take a look at the copy OptiHaul to clipboard, and I'm just going to include the summary and go back to that same spreadsheet, paste it down below here. Big difference you'll notice first of all is that we're doing this by material. And of course if you're only dealing with one material, then they're not all that different. Can I show these? Let's get rid of this thing here. Collapse the ribbon, yeah. Maybe I can get both headings in. There we go. So similar, it's got volume, Same here, except now we've got material, then volume, start station, end station, end station, distance, that's your average distance, and the direction, which is fairly obvious by looking at the stations. So all of these little arrows inside the graph are basically laid out in a text format, and it's the kind of thing you could put on as a label. We don't have an automatic label, but you could type one in here. So, and we've had customers do this where they would put in, okay, what is that lobe there? That's the solid rock coming mostly from the pit and moving into this fill zone over the culvert, and that in the spreadsheet is represented by these ones here. Some of these are a bit small, like you'll notice that one's only 11 cubic meters, not so down here. So you actually have an option when you create this thing to collapse things together for, you know, small volumes and small distances, just pile them together, make it simpler to read. Back to the spreadsheet. So we've got, this is basically the stuff that's happening there. We're pulling material from the pit, a distance, an average distance of 118 meters, and it's going into the fill zone. There it is. Then there's a little bit more material, quite a bit more actually, 8,000 cubic meters, that's actually being cut in that zone. And yeah, so you can see all the quantities, where they come from, where they're going. Now, let's take a look at a couple of other examples. I might pause now for some questions. If anyone has any questions, please feel free to type them in the questions area. Okay, let's look at a couple more examples. Okay, let's go to this one, yeah. Okay, here's an example of a roadway where I have created an alignment using our optimization tool. So I know this is a minimum cost alignment, and it's coming out as 108,000 here. And even if you didn't have the optimizer, you may have come up with this design. Notice that it's mostly balanced. By the way, am I using the right OptiHaul here? No. Notice that it's not quite balanced there, but if I use OptiHaul volumes, I think it will balance. I just double check that. I'm wrong. Okay, there's a reason why optimal solutions don't always balance, and the main reason is that the optimal calculation doesn't calculate every single cross-section, whereas the display for the mass haul does calculate every single cross-section. So sometimes you get a subtle difference. Anyway, not a big difference here. It's pretty close to being balanced, which is what one of the procedures, or pardon me, one of the constraints of the optimizer, and looks fine. Now, watch what happens when I change, whoops, wrong one, when I add in some rock material in the middle. So currently there's rock, but it's way down deep. So you'll notice that we're not actually cutting any rock. If I take a look on here, it's all the top level, which is GT, glacial till. So now I'm going to change the assignment so that the rock comes close to the surface here for a station range. And I'll just recalculate. Oh, did I remember to click on Recast? I'm not sure. Let's see. It'll tell me if it's out of date. It is out of date, so I forgot to click on Recast. So I'll recalculate again. Okay, first of all, notice that the cost has almost doubled. It went from 108 to 195. And the mass haul has changed significantly. There's extra material because rock expands more than glacial till, so there's material left over. The same shape of road gives me different quantities. And yeah, so those are the kinds of things you can read off, and you can click on here and it says, okay, we're moving solid rock and glacial till toward the end here. The interesting ending to this story is that I've created another alignment where I optimized it. Let me just get to that. When you have the alignment properties panel open, or when you have an OptiHaul graphic in your profile window, it will run that that recast function when you open the design. So it can take a little bit longer to open designs. Right, what do we got here? So this is the exact same design I re-optimized using our optimizer, and the software found a new solution where it wasn't cutting as much in this zone where the rock is. It was instead cutting outside and pushing material into that region. You can see that both in the mass haul and in the OptiHaul. And that reduced the price significantly from, what was it, 198 down to 160. It's still more expensive than the original design without rock, and that kind of makes sense. So the cost of excavating the rock where we do have it and the cost of moving the material does add to the cost of the road. So I guess the main point here is that you can get interesting comparisons of costs, and that the cost of both moving and excavating material is included in those values. The absolute value of this number may not be perfect, but if you're comparing one design to another, it's a great way to do it. I got some questions. I got 3 questions. First of all, can OptiHaul be used to track material above subgrade? That's a good question. Yes, we've changed the software now so that you can include materials above subgrade both in the mass haul diagram, mass haul options. Here we go. Subgrade materials and then template materials. And you can also put those materials in the OptiHaul, and it will keep track of them. So for example, you could cut a material, let's say you happen to be building a road through a nice patch of gravel. You could use that material as fill in your layer above subgrade, this gray layer here. And it will keep track of the balance between the two, and so on and so forth. You do that by assigning, okay, I think I need to go into the templates editor and options, materials, here we are. So what I would do is I would say surface 1 above subgrade actually has a material associated with it, and I'd assign it to one of those materials that I find in the ground, and then it would automatically be included in the mass haul and the OptiHaul. Okay, next question. I've got a user who would like to have a couple of example files. I can send those files to you. Yes, that's not a problem. Sidecasting, right. Okay, I didn't mention that, and it's on my list of things to discuss. We've got a question about sidecast. So let me just show you an example of sidecast. I'm going to go to, is this design reasonable? It's not bad. Let's see what happens if we put sidecast in here. So right now, all the materials here are being used along the road. None are being disposed of except in pits. And of course, you can always add multiple pits along the alignment, and that can give you a way of removing material. But we have another way of doing it now, and this is used both for optimization and for just the OptiHaul calculation, the cost calculation. It's in the Constraints tab and under Options. So you do have to open the Alignment Properties panel, get into the Constraints tab, and then there's a bunch of tabs inside of that. Sidecast. So I'm just going to say that we have 5 cubic meters per meter of sidecast available, and I'll put it everywhere. It's possible to limit by the side slope. So, for example, if you're in a mountainous area and you don't want to sidecast on a steep side hill, you could say, well, anything over 65%, I don't want sidecast. Let's make that 55 and see what happens. Say assigned value 5. Let's see what happens when I do that. Okay, yeah, there's a little steep section in the middle here where there's no sidecast, and then there's sidecast up to there and following away from there. I say okay to that. Now, I'm not sure what will happen here. Let's just try it and see. In general, the software will use sidecast when it needs to get rid of material. Yeah, there we go. So now there's no longer any excess material here, and there's a little bit of sidecast shown here, and here, and here. One thing that you should be aware of is that our software is great at calculating the quantity of sidecast, but it's not so great at showing a picture of it. So, for example, at station 1500, we definitely have sidecast. You know, I can zoom in there and see how much. Oh, 1500, yeah, not very much. But my cross-section doesn't show that. What you might see in reality is a little berm on the side here. And I'm sorry we don't draw that picture. If you want more information about sidecasting, feel free to send us an email. The main point here is that, well, let me change the alignment a little bit just to illustrate. If you have material left over, okay, where's my profile gone? There it is. If you have material left over, the software will use sidecast to try and get rid of it. So if I were to just adjust the alignment a little bit here, oopsie. Okay, what do we got now? That's definitely going to have some material left over because I'm cutting all that stuff. And now, oh, and you can only sidecast in the zone where you're cutting. You can't push it along and then sidecast later. You would have to put in a pit for that. So I'm cutting in this zone now, and if I recalculate, I expect to get more sidecast, more of that blue in that zone. And yep, there we go. And then the other thing is, I think, you know, this is something I haven't looked at before. What happens to the sidecast in our summary? Let's just look at that. Okay, so it's not showing up in the movement summary. It does show up in other output. Another question. one of the, this question is about material from another source. Go back to a simpler example. I'm just going to go to this one again, the Hart Road. So let's say, for example, I had a bunch of rock from another design that I absolutely, or another road, an intersecting road or something. In fact, here I think there's a little driveway down here. What happens if I have some material there that I need to use, or some material that I need to generate to manage that driveway? I can do that. So what I would do is create a pit to represent that material. So let's say right here at this driveway, what's that, station 3, call it 300, I have a requirement for some material to go into the driveway. So what I can do is create a pit at station 300. It's a waste pit, but it's not variable, and I'm going to put in a quantity. So let's say 3,000 cubic meters. What kind of material? I can choose whether it's high quality, crappy, medium, whatever. I'll just make it medium quality. And I could also say I want a specific material, but it's easier on the software if you can. It's easier to find a solution if you specify a quality of material, and then it takes a look at your costs. So I think that's good now. Each material has quality. So if you've got gravel left over, Q3 is better than Q2, it'll use that. If you've got solid rock left over, Q4 is better than Q2, it'll use that. Overburden is Q1, not good enough, it will ignore that. So my pit is not a variable pit, it's a fixed pit. We call it a sink in our technoidal fashion if we have to. So this material will be generated somehow. Let's see what happens when I run the software. Recalculate. And it's digging it up over here, and it's putting it in over there. And you can see the little waste dump right there. And you can see some material coming in right here. So the total is still balanced, but it's readjusted how the material is moved, and it may have increased the amount of material coming out of the borrow pit. Yeah, it did. Another question. I'll just read the question. It's yeah, see if I can make sense of it. On a realignment, I want to extend the road design onto an existing road to get the P-line aligned, but I don't want to move dirt as this is already built. Oh yeah, typically what you do there is you just assign a bridge template in the zone where you're not building the road. So in fact, that would make sense here because this road, although I should have a curve on there, this road is actually tracking an old road here. And at some point, we stop the realignment and just go along with the old road. And let's just say it's right here at this station, which is 870. So I can just say assign parameters. Templates, I'll just put in a bridge template from 870 onwards. So the bridge template is no cut, no fill. Don't forget to press add edit, okay, and recalculate. And now nothing happens outside of 870. No mass haul, no OptiHaul. May have messed something else up in here. I don't know, but there you go. Okay, well, thank you all for attending.